गुड इवनिंग। विद्या भारती काशी प्रांत के यूट्यूब चैनल में आपका स्वागत है। कल हम लोगों ने एरर्स के बारे में पढ़ा, मेजरमेंट्स और फिर उनके एरर्स के बारे में पढ़ा। अब उसी को हम कंटिन्यू करना चाहते हैं कि मान लीजिए आप कोई क्वांटिटीज़ को मेज़र कर रहे हैं, मेजर्ड क्वांटिटीज़ हैं। जैसे मान लीजिए कि आप वोल्टेज है इसको मेज़र कर रहे हैं और करंट को मेज़र कर रहे हैं। वोल्टेज का एक मेजरमेंट आपने किया और एक मेजरमेंट आपने करंट का किया, और इन दोनों मेजरमेंट से आपको रेजिस्टेंस की वैल्यू पता करनी है। अब देखिए ये मेजर्ड क्वांटिटी नहीं है, संभव है कि आपके पास एक रजिस्टर हो जहां से आप रेजिस्टेंस मेजर कर दें, ठीक है, ये पोर्शन, लेकिन हम ये मेजर नहीं कर रहे, मेजर्ड वोल्टेज और करंट कर रहे हैं। और तब हम फॉर्मूले का यूज करके आर कैलकुलेट करेंगे। इस केस में अगर एरर हमें निकालना हो, मान लीजिए वोल्टेज को हम कर रहे हैं और वोल्टेज हमें मिला 10 वोल्ट का वैल्यू, प्लस माइनस जो एरर है आपका वो मान लीजिए मिला 1 वोल्ट, ठीक है, ये 10 वोल्ट है और ये 1 वोल्ट है। और वैसे ही जो करंट है वो आपको मिला 2 एम्पियर, और प्लस माइनस जो आप मेजरमेंट कर रहे हैं तो 0.1 का ये, और ये भी आप जो मेजर कर रहे हैं 0.2 एम्पियर, ये आपका प्लस माइनस एरर है। और तब मुझे रेजिस्टेंस में मेजरमेंट करना है। तो रेजिस्टेंस का आप वैल्यू जब निकालना चाहे तो फॉर्मूला आपके पास है V = IR, ठीक है, R निकालना है, सो R = V/I। अब देखिए ये R जो है ये मेजर्ड वैल्यू आपका निकाल रहे हैं। अब मेजर्ड वैल्यू जब V/I निकालेंगे तो ये है, तो सीधा V दैट इज 10 वोल्ट डिवाइडेड बाई 2 एम्पियर, ठीक है, और ये मिला आपको 5 ओम। ये R की मैग्नीट्यूड वैल्यू हो गई, ये 5 ओम यहां पर आया। और जो आपका एरर पॉइंट है इसमें आपको देखना पड़ेगा। तो क्या एरर पॉइंट के लिए निकालने के लिए भी आप करेंगे 0.1 डिवाइडेड बाई 0.2, और अगर आप इसको सॉल्व करेंगे तो आ जाएगा 0.5, ठीक है, 0.1 डिवाइडेड बाई 0.2 और सॉल्व करेंगे तो आपको आ जाएगा 0.5, एंड दिस विल बी द 0.5 ओम। सो इज दैट द रेजिस्टेंस? नहीं, गलत हो जाएगा, इट विल बी द रॉन्ग वन। ये जो हम मेजरमेंट का जो निकालते हैं ना कैलकुलेशन थ्रू एनी फार्मूला, इसमें जो मेजरमेंट्स होते हैं जो डेराइव्ड, जिनको हम बेसिकली आर डेराइव्ड क्वांटिटी है, ठीक है, ये डायरेक्ट मेजरमेंट नहीं है। मेजरमेंट कौन है? V है और I है। आर डेराइव्ड है फार्मूले से। डेराइव्ड में मेजरमेंट जो एरर निकालते हैं वो क्या होता है, इन दो एरर्स का समेशन, ठीक है। तो इन दो एरर्स का जब समेशन करेंगे आप तो बेसिकली ये आना चाहिए 0.3 वट एवर दैट वोल्ट या एम्पियर। अब देखिए वोल्ट बाय एम्पियर, क्या ये भी संभव हो पाएगा? ये भी संभव नहीं है। अब क्या हो कि ये जो पूरा आप एब्सोल्यूट एरर के टर्म में आप निकाल जो रहे हैं वैल्यू 0.3 आप निकालना चाहे, जैसे आप 0.5 0.2 जोड़ दिया, 0.3 कर दिया, डिवाइड कर दिया तो 0.5 आया, ये सब गलत तरीके हैं। और तभी आपको कॉन्सेप्ट याद आएगा कि एक हम रिलेटिव एरर के बाद परसेंटेज एरर की बात किए थे। परसेंटेज एरर में क्या है, इसमें ये डिसाइड नहीं करना पड़ता है कि ये वैल्यू क्या है, ठीक है, हमारा जो मेजर्ड वैल्यू है वो क्या है, क्योंकि परसेंटेज है तो परसेंटेज आप बेस वैल्यू के साथ बदल सकते हैं। मैं कहूँ 10% का एरर है तो आप अगर मेजर 10 मीटर है तो उसका 10% निकाल लीजिए। अगर आप मेजरमेंट 100 मीटर कर रहे हैं तो उसका 10% एरर निकाल लीजिए। 1000 मीटर मेजरमेंट कर रहे हैं तो उसका 10% एरर निकाल लीजिए। तो इसीलिए जो एरर है वो परसेंटेज फॉर्मेट में लिखा जाना चाहिए। तो जो ये प्रॉब्लम है इसको मैं फिर से मॉडिफाई कर रहा हूँ, थोड़ा सा आप देखिए, इस पोर्शन को हम परसेंटेज में लिख देंगे और ये 2% का एरर है, ठीक है, और ये मान लीजिए 3% का एरर है। जब ये एरर परसेंटेज में आ गया, अब हम डायरेक्टली ऐड कर देंगे, तो आर में ये 5% का शिफ्ट आ जाएगा एरर में, तो यहां हम ऐड कर देंगे। तो ये ध्यान रखने की चीज होती है, जैसे जब आप किसी प्रॉब्लम में आपको बताया जाता है कि जो आप निकाल रहे होते हैं कि किसी डेराइव्ड क्वांटिटी में एरर कैसे आता है, कितना मेजर करते हैं, तो आपसे कहा जाता है कि जो एरर्स है उनको ऐड कर दीजिए। बट ये जब हम कहते हैं कि एरर्स को ऐड कर दीजिए, उस समय हमारा कहने का मतलब होता है कि जो एरर परसेंटेज में होना चाहिए, इन एरर्स को आप नहीं ऐड कर सकते, इन एरर्स को आप ऐड नहीं कर सकते, तो इसीलिए परसेंटेज में होना चाहिए। देखिए ध्यान दीजिएगा, whatever we are studying in that physics, whatever you have learned, that more important is you should not learn the misconcept. You should learn the concept, that is okay, but definitely you should not learn the misconcept. So your first job should be rule out the misconcepts, and I'm today talking about the whatever misconcepts we generally follow. So when we say the measurement part, and when we say in the derived part, you just add those errors. In that time, basically I would like to say we want to refer the percentage error. Whenever you see the problem, when you add, that's a percentage error. If the problem is given in this format, and then if I am saying that okay, what is the value for the r, in that case, remember, in that case the r variable you will calculate this way. So this will be somehow 10.1 value or 9.9 value, okay, and here it will be 2.2 or 1.8, okay, and then you will divide it literally. But if it is given in the format of percentage, then you will literally sum that percentage, even whatever the plus minus, nothing matters, okay. So in the same case I will give you the one example. So here you can see one example. Say I have a voltage is 100 plus minus 5 volt, okay, and the current value is 10 plus minus 0.2 2 ampere, sorry, it is 2 ampere. See that. Now I have to find the R. Now I need to convert this error into the percentage format. How much percentage this error is? 5 is the percentage of how much percentage of the 100. So 5, this is the average, this is the value average, the original value, and this is the error. How much is the relative error you can see, and the percentage error. If you see in the percentage error form, this is the 5, but it's called relative error, divided by 100 absolute value, okay. This is the absolute error, this is the absolute value, that's called relative error, and then multiplied by 100. So this is basically 5%, okay. So this error I have calculated into 5%. Again, this is 0.2, so 0.2 divided by 10 into 100, okay. Now this one is 10 and this is 2%, so this one is 2%. Now the resistance is, so the magnitude format will be divide 100 by 10, that is 10, plus error is 7%, and this is 7% of what? 10. So you need to calculate the 7% of 10. How much is the 7% of the 10? Okay, so 7% of this is 0.7. This is 10 plus minus 0.7. This is the ohm. This is the value of resistance. See that I have converted the percentage value. This is the example which will give you the concept of relative error, absolute error, and percentage error. See that I will see from this example. What is your absolute error? The absolute error is for the voltage point. This is 5 volt. Okay. What is your relative error? That is 5 by 100. Okay. This is your relative error. What is your percentage error? This is relative error multiplied by 100. This is 5%. From the one measurement. And then when we are using the derived quantity one, so there you need to convert this absolute error, okay, to the percentage error. This is the absolute value, this absolute error to the percentage error, and then you should find the value of R. You can go for the another problem. Okay, so let us see this problem. There is another problem. See that it is given that there is two resistance, that R1 and that R1 is 100 plus minus 3 ohm, you need to find the resistance in the terms of series combination and the parallel combination. Okay, then the first will be series, we'll talk here, and then we'll talk about the parallel format. Okay, see that we have a measurement again 100 plus minus 3 ohm, then R2 we have some measurement 200 plus minus 4 ohm. Okay, and then they are saying if the connection is made as a in a series combination, or if it is made in the percentage combination. Okay, parallel combination, then you need to find that resistance, net resistance. See here, if you find that in the series part, R is what? R1 plus R2. Simply, R is R1 plus R2. Now, R1 is 100 plus minus 3 plus R2 is 200 plus minus 4 ohm. So, if there is a one thumb rule, if there is any summation, okay, any summation or addition or the subtraction, if the derived quantity is getting out from the summation or derivation, then you don't need to calculate the percentage. Okay, you can directly use that number, because again this is the only addition. So in the addition format you can just add. Okay, so यहाँ पर आप 300, then you can say plus minus 7. See that why I am saying that, understand it. I will tell you that, and then we will go. See, these are the basic problems through which you are learning the concept. You have already studied these parts. In these classes, what we are going to learn is the basic concept we generally miss. Okay, where our flight goes off without looking on the matter. When I am saying, see here I have giving a thumb rule. Okay, I'll tell you the how I am deciding that thumb rule. See that R1 value is 100 plus minus 3. Simple. So its measurement can be, maximum measurement can be a 103 and minimum measurement can be 97. Okay, this maximum measurement can be 204 and then minimum measurement can be 196. So maximum measurement can be, दोनों का maximum add कर दीजिए. So maximum R maximum can be, so this will be the 307 and R minimum can be calculate sorry, add the both minimums. So this is the, I think 293. Yes. Now see here what I have done. Maximum is 307, minimum is that minus 293. See that. It's just some basic mathematics. Here we have used the thumb rule. When you are adding and even you are subtracting, see in terms of subtracting. Let us the formula, this formula, instead of R plus minus R, अगर ये minus होता, okay, and this value should be the R1. Let us consider this value should be the formula कुछ इस तरीके से होता. I will reframe the formula, R2 minus R1. Okay, see that R2 minus R1. तो R2 की फिर maximum value 204, minimum value 196. That is okay. R1 maximum value 103 and minimum value 97. So R2 minus R1. We have to see our R2 minus R1. What will be the maximum value of R2 minus R1? Because we have to calculate the R2 minus R1. So maximum value of R2 minus R1 will be 204, not minus 103, 204 minus 97. This will be the maximum value. So R maximum in this case will be 204 minus 97, and that will give you the how much? So $107. ठीक है. And R minimum, this minus this, okay, 196 minus 103, and this will be the somehow 93. So 196 minus 103, that is 93. Correct? See that. Now if I'll calculate here R2, and if I'll change the formula here bit, and if I'll erase this part now, and from the R2 minus R1, so R2 minus R1 is what will happen? 200 minus 100, that is 100. Okay, and then again, see, remember again, this should be the, again, even there's your derived value is minus, you are subtracting from, you are getting the derived value from subtraction, but instead the error will be the adding one. You have to add the error. So error is a 3 and 4. So this will be the plus minus 7. See that maximum value is a 107, minimum value is a 93. Check that. Again you will get the same number. So even if you are adding or you are subtracting, you are getting your derived quantity from the addition or subtraction, your error value will be the added only. It will be only get the added. I hope you understand that. So in this way done. Now come to the parallel part. So in the parallel part, the resultant one is 1 by R, and that is given by 1 by R1 plus 1 by R2. Okay. Now see that 1 by R1 basically gives you the some division part. Okay, multiplication and division. In multiplication and division, its a formula gets changed. I will give you the one again, the thumb rule for this. So I will erase this part again. if some stage you are not able to get that concept, you may comment there, so that later we can check that and verify you the concepts, whatever you have understand or whatever you are the getting that. Okay, so now the question is, see that if I have a non-derived quantity, okay, z, and that is we are getting from the a cube b square c square d. Let us now, this is a complex one. Okay, you have multiplication, you have power, you have division, all these terms come. If I have to calculate the error in this z, basically what is the thumb rule? You know that the thumb rule in the z is, this is percentage error in z, okay, that is 3, this one, the power one, 3 percentage error in a percentage error, I am saying that, okay, plus, now this is a multiplication one, so due to multiplication it is plus, okay, 2 percentage error in b. Now see that these numbers which are in the division, okay, these numbers are in the division, so you are basically you are dividing that. Now this power will again come to percentage error in c, and then again 1 percentage error in d. Again, see, this is the power 2 and this is the denominator. So someone will say, okay, this goes to minus. No, again I say, in error case you have to add, so this will be again plus, this will be again plus. So by this way you calculate the relative error in a complex number. So before going to this problem, I will give you the one small problem if it is there, otherwise I will design a problem. Oh, so see, okay, I am designing a problem. Leave this problem and I am designing one problem. So let the formula is, this is z, I have given a cube plus b square upon c square d, okay, and now the percentage error, okay, in a is 2%, percentage error in b is 3%, percentage error in c is 2%, percentage error in d is 1%, okay, and then you need to find the percentage error in z. See that simply 3 is the power 1, percentage error in a is 2, so 3 into 2, okay, percent, 2 into 3, b percentage error is 3%, plus 2 into c percentage error is 2%, and percentage error d is a 1%. See that even though it's in denominator, when we are going to get error, it's a positive, that you have to remember. And now it will be the 6 plus 6 plus 4 plus 1, so this comes as a 17%. So you can calculate the percentage error in z as a 17. This is what is called, you get from the any formula. Now see that this formula is very in a simple format. Now come with this formula. When you calculate r, basically you say what is that, r is a r1 r2 upon r1 plus r2, right? You say r is the r1 r2 upon r1 plus r2. Now can you derive this formula? Can you derive this formula in this format? See, this is what you have to learn. In your exams, what will be asked, this derivation only. It means just upgradation of this concept to this. From this format, if they will ask you a question, you will solve. फॉर्मूले में नंबर रखा, कैलकुलेशन किया, यू आर डन. But in exams where the competition is so high, they will not ask that directly. Using the same concept in a standard version, now they will ask like this. And that's why I'm saying, read the book NCERT. They have used all basic derivations and they have used the all basic upgradation of the concepts. You don't need to be a so mathematician for solving this. Okay, you just need to learn basic concepts. See that. Now this is, in this regard, it is very tough to get like this solution, because see that A, B, C, D, these are the variables, they are separate one. Here they are not separate. See, the plus came. Here R1, R2 is multiplication, that is okay. But in denominator it is R1 plus R2. Now that can't be considered as the R3. So there is another that can be considered as another variable. So now this is tough. For this I will tell you the basic method. Okay. So shall we go? Okay, next page we will go. So basic formula is 1 by R is equal to 1 by R1 plus 1 by R2. R is the derived quantity, R1 and R2 are the measured value. See that what you are calculating, you calculate the, see the percentage error. What is percentage error? Absolute error, absolute value into 100, right? See that this number, whatever is that, this is a just, if you see that, it is called derivation. Okay, I will just use a simple basic, since you are a biology guy, whoever is looking for the NEET, there are mostly their subjects are biology, but who study mathematics, they also can understand this concept. There is a difference between the differentiation, okay, that is dy by dx, and then del y by del x. What is dy by dx? Dy by dx, if I write in a mathematics, it is like this one. Understand this concept. This is the error. Okay, this is the error, change in y, change in x. Here you also say change in y, change in x. No, this is when you say d, this is infinitesimal. Okay, so if you have so many measurements, this and this can be, this is y2 and this is y1, and y2 minus y1 can be considered as a del y. Okay, corresponding x2 x1 is here. But for dy, this del x should be very less, so this number should be here only, even though it's closer to this y1. So this is called, this is also a difference, but very small, infinitesimally small step, that difference. So using this basic concept, we will use here, we will see here. Okay, now see that. So if you differentiate this term, what will happen? Minus 1 by r square, okay, and this will we will say del r. In terms of r1, minus 1 by r1 square del r1 minus 1 by r2 square del r2. Okay, so this is del r upon r square del r1 upon r1 square plus del r2 upon r2 square. Now see that these are is the value what we have to calculate, okay, and you see your change whatever you have to measure the value, that is delta r by r. So you have to calculate, multiply by 1 delta r. Now we need r1 r2 value. So what is the r1 r2 value? So we have r1 value, we can write r1 is 100 plus minus 3 ohm and r2 is 66, r2 is here 200 plus minus 4 ohm. Okay, now see that now this is the r which I have to calculate from the this in parallel format, in parallel connection. See that now what I need to change, I have to calculate the one what I have to calculate r, that should be the measured value, okay, that's called magnitude, and plus delta r, whatever the change is. So that net delta r I can calculate here. So r can be calculated directly as a magnitude format, 1 by r is equal to 1 by r1, that is 100 in magnitude format, plus 1 by 200. So this will give you the r is equal to whatever the formula we have used, that 100 into 200 divided by 300, and so this will give you the this cut 100 by 3, that is 66.7. So this is the value of r, 66.7. okay, so even this r will be the delta r by r, that is 66.7. this r will be the 60. So basically we can multiply this also, so we can say that 66.7, okay, and delta r1 by r1 square. What is delta r1? You know the how much change, 3, okay, so 3 upon 100 square plus 66.7, and that I can say square, this should be square and this should be from here go up. This is 4 divided by 200 square, and then you can calculate the delta r. This delta r, whatever you will calculate, this value will be the added here. So this here it will be 66.7 plus this delta r. So this is the basic formula. You don't need to learn any thumb rule. You can do by this way. So I hope that you have learned all these tricks to calculate the error in the derived quantity. Okay, now we'll move to the dimension part. And you can check with these problems the error type problems where we can get, just wait. you can go with the NEET problems, where if you see the NEET papers, if you see any problem related to this, you can solve. See, when you are solving a problem, do not try to deviate so much from the learned concept. Okay, if you have learned from this only, try to keep this as a base. That's remember. Okay, do not try to use that's what called just the tricky ones. Don't use tricky ones. You have learned three ways. You have learned if there is a percentage error, we justly add. Okay, if it is just the addition and subtraction, derived quantities from the addition and subtraction, you just add them. If it is from the so easy formula, z is equal to like this one, these all quantities are derived one and the separated one, then you can use the power and then percentage error. Even though it's a denominator, c square and d is in denominator, it will go past two way. And if this c is not an independent variable, but it also includes c plus d, then you use the basic method. These are the only three methods, and by this way you can solve your problem. For homework, I will tell you this, just give me the see that problem number 2.11, where length, breadth and thickness of the rectangle is given. Okay, and you have to find the area and the volume of the sheet. Okay, so in area you have to multiply, in volume you have to LBH, three components. Okay, so when you're talking about the L and B, and then you are talking about the thickness, that is LBH. So all these are the multiplication, so your percentage error will be the added one in this problem. You can see the 2.13 also, where a physical quantity is given. If you see, physical quantity is given in this way. This is P is equal to A cube B square under root C and D. Okay, so here if you percentage error, if you calculate the percentage error in P, okay, this will give you del A by A 100 plus 2 del B by B 100. See, simple one which I have taught you, 1 by 2, because no negative, even it is in denominator. See that, and you can easily calculate that. The one concept is there, that is called significant number. This is not more important for the exams. Okay, to get that answers. Okay, so what you will say, whatever you have done the measurement. Okay, so let us consider this value may come as a 2.163 unit, whatever unit is. But if your measurement does not consider this number, then your significant digit only will be this one. जैसा कि मैंने कहा कि if you are measuring my height, okay, so it will be feet and inch. Okay, there will be no third one. 5 feet 9 inch, 5 feet 8 inch. If there is something between 8 inch and 9 inch, that is not significant for my measurement, because my measurement is only read about 8 inch 9 inch, 1 inch list count. Okay, and due to this significant number in the list count, the measurements have its own error, that's called significant error, list count error, whatever you say. Let us consider my height is not 5.8 inch, not 5.9 inch. It's a 5 more than it's something more than 5.8 inch and less than 5.9 inch. But your instrument reads only either 5.8, 5.8 or 5.9. So someone is there who is measuring. If he is fond of me, he will write 5.9. Okay. And if he is not fond of me, he will write 5.8. But both are basically wrong. But this is not their fault. It's a measurement fault. And that's why this whatever you count, least count or the significant number, this error will come in the measurement, and that's why there is no measurement that is perfect. It's all depends upon the measuring scale. It's all depends on the measuring scale. So in this way we have learned the concept of least count, significant numbers, and how to calculate the percentage error. Okay. In the next class we will learn about the dimension. Thank you.